So, hello, welcome to the second chapter of this EvilTesuji project. Those PowerPoints we are looking now are old and they come from my other channel. I had an EvilTesuji channel long time ago, but it was in, I don't remember if it was in Java or I don't remember in which language it was at that stage. I am creating the new videos with the same PowerPoints, so we can continue with this in Python because the theoretically idea is the same. So first I will show you this and then I will show you what I'm doing with the code. So let's start with this board representation. So the board, the most common size is 19 and 19, but we have other sizes like 13, 13, 9, 9, because sometimes to teach Go or to learn something, you can do it in a smaller board. But it's also fun to play there sometimes. Anyway, the board can have any size. For this, um, I will only use sizes that are the same. Uh, I will not use irregular sizes. It will be 19 and 19, 13 and 13, 20 and 20. The number is exactly the same. My software should adapt to any size, but both numbers should be the same. There is a GTP command that indicates the size, so there is no problem with that. I just have to adapt my software from the GTP side. It is the same. I will explain later what is GTP. So my program should take any size and generate the appropriate array. The first idea that will come to anybody is to create a two-dimensional array, but it's slower. It's really faster to do it in a one-dimensional array. So we will do a one-dimensional array. Our board will be with one dimension. So how long is this board? We will use a 6 and 6 board for the example. So there is something, it is something like this, right? Our 6 and 6 board. We have these 6 lines that are the positions and the edges, right? So if you see, we can do the one-dimensional array using the first line, then the second line, then the third line, fourth line, the fifth line, and so, right? But you have two edges. If you see in the second line, when it finishes, you have an edge. But the next position, if you have a single dimension array, you will have an edge too. So that edge can be going. Let's see this. This is what we will be actually doing. Because when the last line finishes, the next position will be an edge. So we don't, if we put an edge at the end of the line, you will have two edges, one after the other, right? So this will be a better representation and we'll use less positions than the other. So doing some math, the array size will be n plus 2 per n plus 1 plus 1, right? This n is the number of positions. In this example is 6. So in this 6 board, this will be the count. So we will have an array with 57 positions, right? So our if we added the other edges, we will have 6 more, 63, but with 57 this will work. We will use less memory and this will go faster than a two-dimensional array, so both things are good with this size. So uh, putting this in numbers, this is how it is going to be. Position 1, 2, 3, 4. Yeah. So borders will be in these positions. This is just simple math. If you want, I can do the math for you in a comment or whatever. If you have any doubt, just please ask me and I will tell you how I get these numbers. But if you use some time to do the math, you will go to the exact point where this is. So there are 4 possible elements in our array. 0, that is empty. Let's say 1 will be a black stone, 2 a white stone, and 3 a not playable place. For example, the edges, go, and suicidal positions if we use a rule set that is not allowing suicidal. So that's it for the theoretical part. I will show you now the code I made for this. I am starting to code this, so I will show you. So let's look at the code. I'm using Python to program this. So I have 3 Py files. The main file, where the main loop will happen. The board class, all what happens in the board will happen here. And a printer just to print to the console what is happening. So the main class will import the printer and the board classes. I will create a board with a 9 size. Let's see this board class. It creates, as we saw, an array with this quantity of spaces. I will add a 0 to all those spaces, and then we'll create the borders and add a 3. Well, we'll replace the 0 with a 3. I think I could do better and here put all the borders, but well, it was faster for me to program this to create all the array with 0 size, with 0 value for all positions, and then do the borders, changing the 0 with a 3 in the positions that, well, needed that. And I created a method that will return the board list, the board size, and the total size. I have a printer class that will print everything into the console. Right now it prints the board. It needs some changes, but well, for now and for what we saw in the PowerPoint in the presentation, it will work. So right now what I created is a board with 9 and 9, a printer, and I sent the board to be printed. So if you see, we have 3 zeros. I have to add here the other edge. I have to change it in the printer so you can see it better, and maybe change the numbers with some other characters. For example, I can do, I think, let's try this. I didn't try this, I never tested, but what about 19? Yeah, it works. It should work with any size. Let's see, let's say 5. I am testing this. I didn't test it before, so don't know if it works. Well, yes, it works. So that's it for today. Thank you, and sorry for not being uploading a lot of videos. I have a new daughter at home, so it was hard for me these days to create new content. So see you soon. Bye.